إذا الأمجاد قد عظمت فللأمجاد بانيها ومن يسعى إلى العليا سيدركها بما فيها ويبني مجده جذلا فروح الفذ يعليها ليصبح همة تروي عن العليا.
Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to another explosive episode of the K-Way Math Show here on ITV. I'm your host, Mohammed Kota, host and presenter, Mohammed Kota from the K-Way Institute here in Johannesburg. And as per usual, we will be showing you different techniques and we will be showing you thorough techniques and processes in order for you, the grade 11 and 12 learner, in order to pass maths. Now, where did we end yesterday? We ended yesterday, in yesterday's episode, with the exponential graph. We're now going on to the log graph, and then as promised, I'm going to give you one big compound graph where we're going to be doing graph interpretation. Now, this being a very important concept, we're taking it over a variety of episodes. So obviously all that work, remember this is 2 years work being crammed in 1 hour. So guys, you guys need to bear with me. Okay, now we ended up yesterday with the exponential graph, and we said that the exponential graph was y equals a to the x. The log graph is the inverse function of the exponential graph. So where exponential is y equals a to the x, your log graph is the inverse function x equals a to the y. Now this is specifically targeted at grade 12 learners only. Grade 11s, you don't need to know this at all. Okay, but if you want to start, if you are watching and you are interested in mastering the grade 12 content, be my guest. Okay, now let's explain to you what is a log. So before we actually go into log graphs, let's explain to you what is logs and why do we use logs. Now you do know that when we had 2 to the power x was equal to 8 from our exponential equations, in our answer where we had to solve for x, what did we say? We said we had to make the bases the same. So then we said 2 to the power x was equal to 2 to the power 3. Right? Because the 8 is 2 to the power 3. We made the bases the same. X was equal to 3. What happens? So you as a grade 11 might have asked, or grade 12 learner, what happens if we cannot make the bases the same? So here's the situation. 2 to the power x is equal to 9. Now we cannot make the bases the same. Hence the need for logs. Okay, we use logs when we cannot make the bases the same. Now grade 12s, you're not only going to be using this in functions, you're going to be using this in functions, you're going to be using it in sequences and series, you're going to be using it in finance. Wherever x is in the power, wherever there's an unknown in the power and you need to make the power the subject of the formula, that's when you will use logs. So logs is used when you need to make the power the subject of the formula. So logs is used when we need to make the power the subject of the formula. Hence the need for logs. Why? Let me show you. So if this is the question, 2 to the power x is equal to 9, in your answer we will attach a log. So you attach a log on the one side, you attach a log on the other side. So basically what we're going to do, we're going to say now log, there's it, we've attached a log, 2 to the power x is equal to log 9. Now logs is the only rule in mathematics that allows you to bring the power in front. So the power now becomes the base. This power shifts in front of the log. So what do you have now? In your next step you have x log 2 is equal to log 9. Now it's a normal equation, divide by log 2 because you're solving for x. Remember the question said solve for x. So divide by log 2, x is equal to log 9 over log 2. Now x is equal to, you can go to your calculators, your scientific calculators, punch in there log 9 divided by log 2, you get 3,16999. So you get 3,16999 blah 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 blah. So x is approximately 3,17. And there we go. That is how we solve for x when x is in the power. Okay, so hence the need for logs. Now this The exponential graph, the exponents or exponential equation had an equation. So hence the log graph must also have an equation. Now they are inverse functions. The one is the opposite of the other. So just to show you the log, okay, hope you all took all these notes down. Okay, in the exponential graph, here's the exponential graph, here's the log graph. When we had y equals 2 to the power x in exponents, what did we have? We had a graph that went like this, and we had a graph here. Remember, we had only one y-intercept, 0 and 1. I hope you remember that from our previous episode, that all standard exponential graphs have only one y-intercept, and that intercept was 0 and 1. Now these are the inverse functions. So the log graph for this function will be x is equal to 2 to the y, and sometimes in the exam they will say give the inverse function, grade 12, they'll say give the inverse function of the exponential graph. So if the exponential was y equal 2 to the x, the log graph will be x equal 2 to the y. But they will also tell you write it in the form y equals. They want y to be the subject of the formula. So you just say y is equal to log, what's your base? 2, log base 2x. There we go, that is your inverse function. So these two functions mean exactly the same thing. X equal 2 to the y equal log 2x, exactly the same function. Now, how do we sketch the graph? Now, if they are opposite, if they are inverse functions, grade 12s, if the exponential graph has only one y-intercept, the log graph will have only one x-intercept. Where this point is 0 and 1, the coordinate here would be 1 and 0. So the log graph now would go in that direction, going through the point 1 and 0. So they are your inverse functions. So a positive log graph will look like that. If you had log of a third or log of a half, then the negative graph, log graph, would go in the opposite. So that's the negative, that's the positive. Okay? That's what your log graph will look like. Now the theory, remember in yesterday's episode, we did the theory of the exponential graphs. Let's quickly go through that theory. We said all standard exponential graphs have only one y-intercept. The x-axis is your asymptote. A positive graph is known as an increasing function. A negative graph is known as a decreasing function. We also said that the domain of this graph is x is an element of real numbers, y, and the range y greater than 0, y is an element of real numbers. So now let's do the theory with regard to the log graph. So the theory with regard to the log graph is that all standard log graphs, point number 1, have only one x-intercept. So there we go. Even if they didn't give you that, say they didn't give you this, and they told you this is a point P, X and Y, and it's a standard log graph. They said determine the coordinates of P, X and Y. Again, like we said, it's a no-brainer. All we're going to do now is we're going to say P, X and Y. The coordinates of P, X and Y is P. All log graphs have only one x-intercept, 1 and 0. Right. Which line here? The y-axis or the x-axis? Which line is your asymptote? Which line will that graph never touch? Your y-axis. So in the exponential graph, your x-axis was the asymptote. In your log graph, your y-axis is your asymptote. And what is the equation of your y-axis, guys? X equals 0. Right. We now have the domain of this graph. What is the domain? Which x values here will give you corresponding y values? Will this graph ever touch y? Will ever touch the y-axis? No. Will it ever go to the negative y? No, it will never. It will only be to the positive side. So we'll say x greater than 0, x is an element of real numbers. What is the range of that graph? Which y values? Any y, because this goes on to positive infinity, this goes on here to negative infinity. So any y value from positive to negative. So we say y is an element of real numbers, or we can say from negative infinity to positive infinity. And that is your standard questions that can be asked on your log function. They might tell you on the same set of axes, draw the inverse function of that log graph. So obviously the inverse function is the exponential, and the exponential will go that way. Where this graph goes through 1 and 0, the exponential will now go through 0 and 1. Okay, where this graph is x equal 2 to the y, the equation of this, so if this is h of minus 1, the inverse function, the equation of that will be 2 to the power x because your base is 2. So this is the graph log 2x, and that is the graph 2 to the power x. Okay, top one being your exponential, bottom one being your log. Remember, they're related. Where exponents ends, logs takes over. They come from the same family, but they are opposite. Okay, so here goes. So this is the log graph. If we wanted to find out grade 12s, if you wanted to know what is the inverse function, now we're going to be doing inverse functions, right? So now, you know this is a typical grade 12 concept, the inverse function. This has been added to your grade 11 content to make it your grade 12 content. So your inverse function, very two basic rules on there. You swap the x and the y, swap the x and the y, swap x and y, and number 2, make y the subject of your formula. So I'm going to give you one before the ad break, and I'm going to tell you f of x is equal to 2x plus 8. I want the inverse, grade 12, I want the inverse function in the form f of minus 1x equals whatever, for 4 marks. You've got time now during the break. We're cutting for an ad break. When we get back, we'll be continuing with the memo for this. Hope you enjoyed the session.
الأمجاد قد عظمت فللأمجاد بانيها إذا الأمجاد قد عظمت فللأمجاد بانيها.
Boys and girls, welcome back to the K-Way Mathematics show. We ended before the ad break with a question. I hope you guys got it done. Grade 12s, I hope you started working on this, the inverse function. We said swap the x and the y, make y the subject of the formula. So if that was the question, in your answer, you know f of x represents which alphabet? Y. So y is equal to 2 to the x. That's not the inverse function, that is the original. We now need to give the inverse. Inverse means the opposite. So swap x and y. Let's swap the x and y. So instead of y equals 2x plus 8, we're now going to say for your inverse function, what are we going to say? X is equal to 2y plus 8. So there we go. Right? If I give you rules, if I give you steps to do, I want you to follow it religiously, step by step. I'm not going to give you a rule and you're not going to be using it. Okay? So we swap the x and the y. So we swap the x and the y. What did I say? Step number 2, make y the subject of the formula. So what do we have now? We have 2y is equal to x plus 8 will go over as minus 8. We divide by 2. Remember, make y the subject of the formula. Divide by 2. It's an equation. What I do to one, I do to all. So y is equal to x over 2 is a half x minus, you can say x over 2, but we rather put it as half x minus 8 over 2 is 4. And they want it in the form f of minus 1. So f of minus 1x is equal to a half x minus 4. And there we go. That is the inverse function for 4 marks, the inverse function of that straight line. You will do it. It's a generic rule. Generic means it can be applied to anything. So take all your functions, whatever functions you have, right? If the minute they tell you, give the inverse function, swap the x and the y, make y the subject of the formula. That will be your new function. Now you sketch the function. Now, what happens, this is a typical grade 12 concept. Now grade 12s, I need you to pay attention here. Right? It comes in all your past papers. They now give you a graph, they give you a parabola that looks like that. Okay? Now, this is 0. They now tell you that this is graph f. Now, we know that f is a function. What is a function? A function is a one-to-one relation. For one x value, you must get one y value. One x value, one y value. Choose any x value. You'll get one corresponding y value. Now, what we're going to do, so you got one x value, so a one-to-one function, one-to-one is a function. A one-to-many is a relation. Meaning that if you got one x value and you got many y values, that is a relation. So, is this a function? Yes, it's a function. Why? For one x value, you got one corresponding y value. Right? They're going to ask you in the exam. On the same, now you know that this is pointing to the positive y. They say on the same set of axes, draw the inverse function of f, in the called f of minus 1. So on the same set of axes, if this is pointing to the positive y, the inverse function is going to point to the positive x. So the graph is now going to go in that direction. and that is going to be called f of minus 1. Okay? If this graph was a negative function, for example, and that was the original graph, and they now said draw the inverse function, this graph is pointing down to the negative y, so obviously the inverse function will be pointing to the negative x, and that is f of minus 1. That is your inverse function, your opposite function. Okay, now they're going to ask you, is f of minus 1 is the inverse function of the original function? Is f of minus 1 a function? And I know you're all sitting there in your lounges, or you're all sitting there watching the program, and 99% of all you grade 12s are already answering the question, no, it's not a function. Exactly. And you are 100% right. Right? You can't always be wrong. Okay, so we got no, it's not a function. Why is it not a function? Because for one x value, for one, if I do the straight line test, if I draw a straight line here, how many times does my straight line cut this? It cuts it once, cuts twice. So the inverse function is not a function. For one x value, I've got many y values. For one x value, I got many y values. So it's not a, is f of minus 1 a function? No, it's not a function. Why? Because it's a one-to-many relation. One-to-many relation. Meaning that for one x value, you've got many y values. Okay? How would you restrict? This is another exam question. How would you restrict the domain in order to make f of minus 1 a function? How would you restrict the domain in order to make this a function? So you're now going to say, if I close the bottom part of the inverse function, the top half is a function. If I close the top half, the bottom half is a function. So we're going to say for y greater than 0 or for y less than 0. And that is how we restrict the domain in order to keep this a function. Because if I close the bottom half, the top half, y greater than 0. If I close the top half, the bottom half is a function. So y greater than 0 or y less than 0. Okay? That is now to do with inverse functions. I think we're all okay with inverse functions, I'm hoping. If you still don't know it, get our DVD set. Okay? It's being advertised. You'll see it in the bottom right-hand corner. Pop us an email, kwmath@gmail.com. We'll get the DVDs out to you as soon as possible. Okay, let's now go on to, now we're going to do that application. As promised, we're going to do that one big graph, and we're going to apply everything in one, because you're not going to see all these graphs in isolation. Yes, you might see the hyperbola with the shift in asymptotes, you might see it in isolation, right? But majority of the graphs, your parabola, your straight line, your exponential, will all be on one function. Let's now start. So I'm going to give you a situation like this. You can take this down, right? We draw a graph that looks like that. We then do this, going through there. Right? I call this point A, I call that B, I call this C, I call that D. The distance between here and here, we put that A, B, C, D. Let's call that E, let's call that J and K. That's O. O being your center, that's your y-axis, that is your x-axis. Okay. Now, let's put down your equations of this graph. And I'm going to give you another one. And we take another graph and I put it down here. And I call this graph H. And I tell you this is the point P, -3 and y. There we go. Take down that graph. And now let's start asking you questions with graph interpretation. Now, obviously, all the processes were not shown in the show. So you need to have watched the previous shows in order to be able to attack this, right? Go back to those processes and procedures that I showed you. All the processes with regard to a straight line, all the processes with regard to a parabola, all the processes with regard to the hyperbola. Okay, let's get started. I tell you here, this is graph F, that's graph F, that's graph G, that's graph H. So I tell you f of x is equal to x squared minus 2x minus 8. I tell you g of x is equal to mx plus, let's give it a different value. Mx plus q, yeah, let's call it mx plus q. I tell you h of x is equal to its hyperbola, so I tell you a over x. That's given in your exam. Now, a question like this can be built up to about 50 marks. 50. Why? Because it's graph interpretation. They can ask you a variety of questions. We're going to try and go through as many as we can. This is grade 11 and 12. So please make sure you stay focused. The first question, let's do it in stages. The first question is, they say give the length of AB. They want the length of AB for 6 marks. Question number 1, they want the length of AB. Now, the question that you've got to ask yourself all the time is, what is? That's the question that you've got to ask yourself in your mind all the time. And you do know that if your answer is not on the graph, it must be in your equation. If it's not in your equation, it must be on your graph. If it's not in the one equation, it must be in another equation. It has to be somewhere on the board. It can't be. You're not sucking thumb. You're not pulling figures out of your thumb. The answer is on there, either in the equation or on the graph. So let's get started. What is AB? So what is A? What is A? What is B? A and B are what? They are your two x-intercepts. Your x-intercepts of what? Of your straight line? No. They are the x-intercepts of your parabola. So now we go to our parabola. How do you find x-intercepts? Go back to the episode where I taught you guys how to find your x-intercept. You say let y equal 0. Let y equal 0. So if y is equal to 0, you got x squared minus 2x minus 8 is equal to 0. Factorize that equal to 0. You got x and x, 4 and 2 minus plus x is equal to plus 4, or x is equal to negative 2. So there we go. We go back to our graph. So this has got to be 4 and that has got to be minus 2. They want the length of AB. Can distance ever be negative? No. So OA is 2, OB is 4, OA is 2, OB is 4. Therefore, AB is equal to 6 units. 2 plus 4. 6 units. Okay? Guys, take this one down. We're going to cut now for an ad break. I'm now going to give you the second one that I would like you to do. I want you now to find the coordinates of C, and number 3, I want you to find the coordinates of D. The coordinates of D, which is the turning point of F. Okay, you guys got 3 minutes to do it. When we get back from the ad break, we'll continue answering this graph.
الأمجاد قد عظمت فللأمجاد بانيها إذا الأمجاد قد عظمت فللأمجاد بانيها.
Boys and girls, welcome back to the K-Way Math Show, where we're showing you shortcuts, we're showing you better methods in order to prepare you for the exams in grade in 2015. Okay, before we cut for break, this is what we did. We gave you a complex graph and we started asking you questions. Question number 1, we wanted the length of AB. Question number 2, which I gave you guys to do during the break, and I hope you did it. I want you to find the coordinates of C. Right. So again, what did I say? You've got to ask yourself the question all the time. What is? What is? What is? So what is C? Right. What is C? C is the y-intercept. Okay, so the answer to question number 2, the coordinates of C. C is the y-intercept. Yes, it's the y-intercept of two graphs. It's the y-intercept of the straight line. Yes, there's it. But do we have it from here? No. But it's also the y-intercept of your parabola. Do I have it? Yes, I do. So I know that this here is negative 8. I know C's y value is minus 8. So what do? Obviously, C's coordinates is 0 on my x, minus 8 on my y. Finish, game over. Full stop. Where did I get it from? I got it from there. Number 3, the coordinates of D, the turning point. Now I did tell you guys, in the previous episode when we were doing processes, the formula for calculating your turning point. Your turning point minus b over 2a and 4ac minus b squared over 4a. So minus b over 2a minus, now remember we're using that formula, a, b, c. So minus b minus 2 over 2 into 1. Now we've got 4 into 1 into c is negative 8 minus b squared minus 2 squared over 4 into a is 1. So 2 over 2 is 1. 4 times minus 8, minus 32 minus 4, minus 36 over 4 is minus 9. We know D's coordinates is 1 and minus 9. So they wanted the coordinates of D, so you put D, 1 and negative 9. There we go. Okay? Hope you're following. Question number 4. Find M and Q. Question number 4. Find small m and small q. Do you see a small m on the graph? No. Do you see a small q on the graph? No. So if it's not on the graph, where must it be? In the equation. What does m represent? What does q represent? Q is your y-intercept. So here we go. What is q? Q is your y-intercept. Same as my c value here, because that's where my graph cuts on my y-axis. So q is minus 8. What is m? I showed you guys the shortcut when we did process. I said change the sign of y over keep the sign of x. So that's plus 8. Minus 8 becomes plus 8. Plus 4 stays as plus 4. 8 over 4 is 2. So there we go. We've now found m and q. So q is equal to negative 8. M is equal to 8 over 4, which is 2. We go back to our equation. We take this out. Take m out because we know we're right. We put a 2. And we know this here, the q value here is the same as the q value there, minus 8. Okay. Now remember, the minute you get answers, you throw it on the graph. We never work from calculation. We work from our graph or we work from our equation. Okay. The next question. Find the equation of h for 6 marks. Find the equation of h for 6 marks. Question number 5. There you want. Find the equation of h. 6 marks. What is h? H is your hyperbola. There's your equation. What alphabet are we looking for? A. So we got h of x is equal to a over x. Remember I showed you the shortcut. I said you multiply the x and the y. But do we have the y value here? No, we don't. So what do we need to do first? Get the y value. How do we get the y value? Isn't it the same x value for the parabola? That's the same x value for this. So I just take the negative 3 from my hyperbola and I plug it into my parabola, because at that point the two graphs are the same. It's the same x for both graphs. So what do I do? Step number 1, find the equation of h. If that's your question, this is where you're going to start answering in your exam. You're now going to take in your parabola. So now you're going to say f of negative 3. The function value of negative 3. That means for every x, I'm going to plug in negative 3. So I've got negative 3 squared minus 2 into negative 3 minus 8. What do I have? Minus 3 squared is 9. Negative times negative is a positive. 2 times 3 is 6 minus 8. 9 plus 6, 15. 15 minus 8, 7. That means the y value, where x was minus 3, the y value is 7. That means this y value here is 7. Now we got the x and we got the y. We now find the equation. So h of x is equal to, I told you guys the shortcut, just multiply these two. Negative 3 times 7 minus 21 over x. And there we go. Boys and girls, that is your final solution. It's worth 5 to 6 marks. Okay, you took the x value, you plugged it into the parabola to get the y value, because it's the same x and the same y at that point, multiplied those two in order to get its final equation. Alright, they might now ask you, find the length of EJ. I'm going to erase here. Question number 6. Is it 6? 7? Who cares? Right. Find the maximum length of EJ. If OK is equal to 10 units. Find the maximum length of EJ. You know, this is a very popular question. They want the maximum length of EJ. That means they want that if OK is 10. So in my answer, we know OK is 10. That means K's x value must be 10. Its y value there is 0. Because all these points lie on a straight line, if this is 10, J's x value must be 10. E's x value must also be 10. Why? They all lie in a straight line. The straight line goes through 10. Now, how do we find that distance? We need the y value on the top. So say we got the y value as 100. And say we got this here as 20. So obviously EJ will be 100 minus 20. Top graph minus bottom graph is equal to your length. So we're now going to take 10. We're going to take 10 and plug it into parabola for E. For E, we're going to say f of 10 is equal to 10 squared minus 2 into 10 minus 8. 10 squared is 100 minus 20 minus 8, which is equal to 100 minus 28, 72. So we got this here to be 72. Now we take J. J's 10, does it lie on parabola or on straight line? On straight line. So we go G of 10. G of 10 is equal to 2 into 10 minus 8, which is equal to 20 minus 8, which is 12. So now we got that value as 12. Now if the distance from here to here is 12, and the distance from there to there is 72, so obviously EJ, therefore EJ is equal to 72 minus 12, which is equal to 60 units. And there we go. That's your final answer. You will get 5 to 6 marks for that. Please make sure top graph minus bottom graph is equal to the distance. If they gave you the x value, very simple, take the one x, plug it into the one equation, take the other x, plug it into your other equation, subtract the 2, and you will get your you will get the maximum distance between the 2 points. But now comes the tricky one. What if they didn't give us that? What if they didn't give us the x value? Now grade 12s, here you can use derivative. Grade 11s, now grade 12s you can use a grade 11 system or a grade 12 system. Grade 11s obviously you cannot use derivative because derivative forms part of calculus. So let's get started. What if they didn't give us? What if they told us, find the distance of the maximum length of PQ? Find the maximum length of PQ, and they didn't give you P's coordinates, and neither did they give you Q's coordinates, and neither did they give you an x value, and it's worth 6 marks in the exam. So that's P. They want the maximum length of PQ, right? So question number 7, find the maximum length of PQ. Here no x value was given. I told you, if the x value was given, very easy. Plug it into the one, plug it into the other. Now you got top value, you got one above, one below, you'll add the two distances, if that was the case. If both are above or both points below, you'll subtract. If one point is above, one point is below, you add the two y values to get the maximum length. But here nothing is given, and that's 90 degrees. What do? Obviously we say top graph minus bottom graph. So to get PQ is equal to top graph minus bottom graph. What's your top graph? What is your top graph? Your parabola. And what do I have? X squared, so it's graph F minus graph G, which is equal to x squared minus 2x minus 8 minus, what is graph G? 2x minus 8. So now we're going to be left with x squared minus 2x minus 8 minus 2x plus 8. We are now left with x squared minus 2x minus 2x minus 4x minus 8 plus 8 is 0. So PQ's distance, guys, is x squared minus 4x. Top graph minus bottom graph is given by now an expression, x squared minus 4x. They want the exact length. They don't want an expression. They want the exact length. How do we do it? This is where we start. We now go and we complete the square. Guys, we now complete the square. So we say PQ is equal to x squared minus 4x. What did I show you? The shortcut of completing the square. Divide the coefficient of x by 2 minus x squared. If you don't know, you'll have to go back to the previous problem. So what do I have here? I got x squared, x minus 4 divided by 2 is 2 squared. There's no value here, minus. Now take this value and square it, 4, which is equal to x minus 2 squared minus 4. There's your maximum distance. Therefore, maximum distance is your Q value, which is equal to 4 units. I bet many of you didn't know that. Okay? Guys, we're cutting now for an ad break. Please make sure you take this question down, go through it quickly, and we'll see you after the break.
الأمجاد قد عظمت فللأمجاد بانيها إذا الأمجاد قد عظمت فللأمجاد بانيها.
Boys and girls, welcome back from the break. I hope you've taken this problem down before the break, before we cut for the ad break. That's where we left you. We told you to find the maximum distance of PQ if this wasn't given. So there we go, x squared PQ is equal to, we took top graph minus the bottom graph, we got an expression. We then took the expression and we completed the square, right? I showed you guys the shortcut on how to complete the square, and we get the maximum distance. We just read it off here as 4 units. Now, by now, grade 12s, you should have done calculus already. Right, this time of the year, we're like 1 month before the prelim exams. I'm just going to show grade 12s, grade 11s, here you can log off. Grade 12s, if you have done calculus, I'm just going to show you quickly how it's done. So obviously, if we're not going to complete the square in grade 12, then how are we going to do it? Right, so obviously, we're now going to use the derivative, right? We're now going to say the derivative of this is going to be 2x minus 4. 2 times 1 is 2x minus 4 is equal to 0. Right, your derivative equal to 0, 2x is equal to 4, x is equal to 2. Now you got x is equal to 2. You can take this 2, plug it back into the original, and what do you get? You get PQ's distance is equal to 2 squared minus 4 into 2, which is equal to 4 minus 8, which is equal to minus 4. We know that distance can never be negative, so obviously PQ's distance is 4 units. So this is using derivative method. The other method that we showed you, complete the square. After completing the square, writing it in the form a into x minus p all squared plus q, just read off the q value. The q value is your maximum distance. Okay, let's go on. Question number 8. Question number 8. So we got this one's equation as minus 21 over x. Minus 21 over x. Okay, they now tell you to give, question number 8, they tell you to give the domain of h. Now the domain of h is running this way, so x less than 0, x is an element of real numbers. They want the range of f. The range of f, the lowest y value here is negative 9. It's going from negative 9 up to positive infinity. So minus 9 up to positive infinity, minus 9 included, so we put a square bracket because that's my lowest y value here. It will be all y values from negative 9 up to positive infinity. Okay? They could now ask you to give the inverse function of g. You know how to do it by now. Swap the x and y, make y the subject of the formula. They might also tell you, right, what about your rules of reflection? So quickly, before we end off today's program, let's quickly do the rules of reflection. Something that we didn't do earlier as part of our theory, let's do it now. So now, if they told you, okay, let's erase all of this now. Let's do reflection. So say they gave you a hyperbola and they told you h of x was equal to 4 to the power x. Right. Now they tell you to reflect this. Here are your rules of reflection. Please guys, learn these reflection rules. The rules of reflections will apply generically to all topics. So you only have 4 possible reflections. You have a reflection about the x-axis. You have a reflection about the y-axis. You have a reflection about the line y equal x. And you have a reflection about the line y equal negative x. Okay, there we go. These are our 4 rules of, so they say give the new equation h of minus 1 if h of x is reflected about the x-axis. So here are your rules. Okay, so please memorize this. Take this down and remember it. When you reflect something about the x-axis, the y sign changes. When we say y negative, we say y sign changes. Right? So y sign changes. Reflection about the y-axis, x sign changes. Reflection about the line y equal x, the 2 swap over, the signs don't change. Reflection about the line y equal negative x, the 2 swap over, both signs change. Okay, so let's reflect this one about all these x's. So reflect h of x about the x-axis, y sign must change. So h of minus 1x will equal to 4 to the power x. They say the y sign must change. So now the y sign must change to minus. But in your final answer, can this ever be negative? No. So your final answer is going to be h of minus 1x is equal to, divide by negative, minus 4 to the power x. So that was h of x reflected about the x-axis. Your y sign changed. Reflected about the y-axis, x sign must change. So h of minus 1x will equal to 4 to the power, if it's plus x, must become minus x. Reflected about the line y equal x, the two of them must swap over. So this is y equal 4 to the x, so this one is x equal 4 to the y. And what do we know? Doesn't that look very familiar to one of the graphs that we did? We did it in the log graph. So x equal 4 to the y is the same as saying y equals log 4x. So not only is it the inverse, not only is the log graph the inverse of an exponential graph, but it's also the reflection of the exponential graph about the line y equal x. Why? Because that is the rule that makes the two of them swap over. Okay, and then the line y equal minus x, so you're going to have minus x is equal to 4 to the minus y, and x is equal to minus 4 to the power minus y. And there we go. This one here, they'll hardly ask you to reflect it about the line y equal negative x. The three main ones that they will ask you reflection rules will be your first three. Okay, boys and girls, that now brings us to the end of functions. I hope you guys enjoyed our segments. I hope you enjoyed this episode of it. Stay tuned, grade 12s. Our next episode is going to be calculus. Stay tuned, start working, start preparing, and go through all your calculus notes, and then let's compare notes. When we get started with the program, I'm going to show you my methods. You can then phone in. We are going to be having a live show. You can then phone in, show us your methods. If you got better methods, we welcome you into the studio. So contact the studio if you'd like to be a part of our show as well. Please, if you've got better methods, if you feel like you want to be part of this, remember this is a collective effort. What we are trying to do is to inspire the youth. What we want to do here is to revolutionize mathematics in this country. We want to create a mathematics revolution and a mathematics explosion. So please, guys, even if you are youngsters, grade 11, 12, you want to be part of the studio, please walk in and come and show us what you have in studio. Boys and girls, stay tuned. Thank you very much for joining us on the session. Hope you guys enjoyed this bumper edition of K-Way Mathematics, and stay tuned for our next episode on calculus.
الأمجاد قد عظمت فللأمجاد بانيها ومن يسعى إلى العليا سيدركها بما فيها ويبني مجده جذلا فروح الفذ يعليها ليصبح همة تروي عن العليا